Hi students, now we are going to study work kinetic energy theorem, which is otherwise also called as work energy theorem. So what is the statement of this theorem? The work done by the force acting on a body, the work done by a force acting on a body is equal to the change in kinetic energy of the body. Very simple. We are going to consider a body on which a force is going to act. Because of the force, the kinetic energy of the body is going to change. This relationship only is called as work energy theorem or work kinetic energy theorem. Now, we are going to prove this theorem. Statement is written here. Like that, proof we are going to derive, that's all. Now, you can see an object of mass m is traveling with an initial velocity u. Okay, m is the mass of the body which is traveling with an initial velocity u at a point A. Then I am going to apply a force on this body which is already traveling at initial velocity u. I am applying a force. See, for example, a person is riding a bicycle. He is going on a bicycle with a constant speed of 2 meters per second. Suppose if you go behind and push the cycle in the forward direction, what will happen? Will the speed increase or not? The same situation. Already the body of mass m is having an initial velocity u at the point A. In addition to that, now a force is acting on the body. F is acting on the body in the same direction, so that the velocity of the body of mass m changes from u to a final value v. That means, what is the effect of the force here? Because of the force, the velocity of the body has changed. That means the body is accelerated and it travels from A to a new position B, so that its final velocity at the point B is equal to v. So the initial point is A and the final point is B, so that the displacement along this straight line, that is the shortest distance AB, is equal to S. That is called the displacement of the body. So the force F acting on the body of mass m has accelerated the body to a position B. Okay. Now, since the force acting on the body has produced a displacement, a work is said to be done. The work is said to be done. So, the work done by the force, the work done by the force is given by the expression W is equal to F into S into cos theta. Here cos of 0. Because the force F as well as the displacement both are acting along the same straight line in the same direction. Therefore, theta is equal to what? 0 degree. Cos 0 is equal to 1. So, cos 0 is equal to 1. Therefore, W is equal to F into S. So, this is equation 1. Okay. Now, according to Newton's second law, there is a relationship between the force acting on the body and the acceleration of the body. So, from Newton's second law, what is the expression relating force and acceleration? That is a mathematical form of Newton's second law, that is F is equal to m into A. So this is another equation. Now, at the initial point A, the velocity is u, and at the final point B, the velocity is v. Now I am going to consider the equation of kinematics, the third equation of kinematics. So, from equation of kinematics, there are three equations. What is the third equation? From the equation of kinematics, the third equation I am going to write now. So, what is the third equation is? V square is equal to u square plus 2as. I shift the u square term to the left hand side, so that v square minus u square is equal to 2as. or I can write the same in different form. I want an expression for A. So the acceleration A is equal to v square minus u square divided by 2s. This is equation 3. Are you all able to see the equation? Okay. The third equation is for the acceleration of the body, that is equal to v square minus u square divided by 2s. This expression for acceleration in equation 3, I am going to substitute in the equation 2. Okay. So, now F, the force F is equal to mass into acceleration. Instead of acceleration, I am going to substitute v square minus u square divided by 2s. Mass into acceleration. And once again, this expression for the force F, I am going to substitute in equation 1. This is equation 1. Work done is equal to force into displacement. Okay, therefore, work done is equal to force into displacement. So, this is equal to m into v square minus u square divided by 2s into displacement is s. So, the term displacement s is getting cancelled. So, this s and s getting cancelled, or what is now w is equal to m into v square minus u square divided by 2, or once again rewriting this, w is equal to, this is m into v square by 2, is it not the first term? So, it is half m v square minus of m into u square by 2 is what? Half into m u square. So, this is equal to half m v square minus half m u square. So, this first term, v is the final velocity of the body. Therefore, half m v square must be equal to what? Final kinetic energy. Kinetic energy at the final point, at the point B, minus of u is the initial velocity of the body. Is it not? At which point? A. Therefore, at the point A, what should have been the initial kinetic energy of the body is half m u square. So, the second term half m u square must be equal to what? The initial kinetic energy. Understand? So, this difference between the final kinetic energy and the initial kinetic energy is called as change in the kinetic energy of the body, which is denoted by delta Ke. Delta Ke. That means change in the kinetic energy. Okay. Therefore, I can write W is equal to delta Ke. So, this is the final equation number 5. Okay. Or 4 I will take. This is equation 4. So, now what is the left hand side? W. W is called the work done by the force acting on the body. What is on the right hand side? Change in the kinetic energy of the body. Now you can read the statement once again. Work done by the force acting on a body is equal to the change in the kinetic energy of the body. Have you all understood? This is the proof for the work kinetic energy theorem, or simply work energy theorem. Now there are some points called as facts or implications from this theorem. What are the implications? What are the points which can be understood from this? This work done may be positive or negative depending upon the direction of the displacement. You have studied that if the force acting on the body and the displacement produced are in the same direction, means what? Work done is positive. If the force acting on the body and the displacement are in the opposite direction, means work done is negative. If the force acting on the body and the displacement are perpendicular to each other, means then the work done is 0. Is it not? Depending on that. So based on that, we are going to mention the implications. So what is the first point of the implication is, if work done is positive, okay, if the work done is positive, means then the kinetic energy increases. Understand? The kinetic energy of the body increases. Next, if the work done is negative. If the work done is negative, then the kinetic energy of the body decreases. Okay, the kinetic energy of the body decreases. Okay, suppose if the work done is 0, the third point, if the work done is W is equal to 0, then this left hand side is equal to 0. So that KEF minus KE initial is equal to 0. Therefore, what? The final kinetic energy is equal to what? The initial kinetic energy, is it not? So, in this case, KE final minus KE initial is equal to 0. Or this KE final is equal to KE initial. Is it not? So, the final kinetic energy is equal to the initial kinetic energy, means there is no change in kinetic energy. So this no change in kinetic energy. These are the three implications. So what is the statement of this work kinetic energy theorem? The work done by the force acting on a body is equal to the change in the kinetic energy of the body. I hope you must have understood. Fine.